All right, today is Monday, the 22nd of February. Two things we're going to do today. The first thing we're going to do is I'm going to talk about the first assignment. And the second thing we're going to do is I've got the code out there already. We're going to look at that game. It's pretty much in its final form now. And, well, that's it running, but that's it running on a mobile device. It's not great, but it's not too bad either. It looks like this now. So, there it is. So that's what we'll look at today. But first, I wanted to say a few words about the first assignment. Now, looking in there, many of you who are in this class, I did not have. Last semester, I taught the 157 class online. And I know there's a few of you who are in here who took that class with me. But by and large, most people did not. And as I was looking at the way that some of the websites were built, it got me to wonder, and I'm going to say this, it's going to sound terrible, but I don't know any other way to say it. What the hell did you learn in that class? I'm being serious. With some of them, I'll tell you what, I'll put them up on a little bit of a pedestal. Corey, yours was fantastic. I'm serious. It was so good, I couldn't believe how good it was. All right, and there were a few other ones that were really good. All right, but there were a lot of people who either didn't turn in anything or turned in a page that they looked like they copied from someplace else, or I don't know what. So it just got me to thinking, and it's just funny, I mentioned this to Luke before class because Luke is a second-year student. And he was talking to me about some of the foibles that he's had. Now, literally, he had an instructor for the 119 class, the JavaScript class. It got so bad in there, John was the lab assistant the whole year. She wrote 5 lines of code on the board for the whole semester, didn't go over any other code, and for the last 3 or 4 periods showed my videos. And I said, what'd you learn? And he basically said, not a flipping thing in there, other than what I learned myself. So, I mean, he's proof that you can go through a class like that and maybe not learn a lot, but still learn, even if you end up learning on your own. But I looked at some of the ones that were in here, and it just made me wonder how much basic website development experience do you have? Because I looked at some of the stuff that was in there, and like some of it, as an example, if you don't know this already, if you create a form and you do no formatting on it, it looks like you did no formatting on it. Seriously. I mean, in the worst case, what you could always do is you could put it into a table and at least put some formatting in there. Or you could do a display block type of thing and have, on one line would be the heading and then on the next line would be the text box or whatever, and you could do it like that. But with some of you, I mean, the stuff was literally just waved all over. And I can't see where it would be, well, we didn't have time to work on it, because you did have time to work on it. All right? And some people did a real good job as far as incorporating images and the like. Some people put stuff in there but didn't put in everything that was asked for. Skylar did a really good job of the forms, kind of breaking it up into 2, and having the one thing where you asked the information and the other stuff was more about the other stuff that I asked for with the radio buttons and the like. All right, but a lot of people didn't even put some of that stuff in there. All right, some people didn't have a homepage. All right, and you know who you are. I'm not ripping on anybody. I'm just talking to you about the way that it was. All right, it's a good thing I created the Java first. All right, because after I finished that, I wasn't in a very good mood. So I wouldn't have wanted to grade the Java afterwards. I've changed. It's like one thing about me. I don't grade anymore during football season when I'm watching a Packer game. My wife doesn't let me do that. We put our dog down last summer, and she's kind of sure that the dog maybe lost part of its life because of the fact that I'm getting like this. I'm swearing at the television and everything, and the dog is just literally sitting there shaking like crazy. She picks the dog up and takes her into another room, and it's like, okay. So what I'm going to do is today we're going to go over as much of this as we can with this example that I'm showing you. If we get through all of it, fine. If we don't, fine. Then we'll finish it up on Thursday. But I want to give people that haven't turned the assignment in some more time to work on it. Now, you'll still get points. You won't get as many points as the people who turned it in on time. All right? But hopefully, you've got a grade out there, and I wrote some comments on it also, okay? With some of them, even if you turn something in, if there's no grade there, it's like I really didn't feel like I had enough to grade. Does that make sense? All right. But like I said, with some of them, they were just, I couldn't believe how good they were. And other ones, there just was nothing there. All right. And a lot of people's were right in between. I mean, a lot of people did a very nice job. They followed all the instructions. They did everything. They didn't have the images and stuff, which was okay because you weren't asked to do that yet. Other people spent a lot of time on that. All right. And again, everybody's going to be different as far as the way that they do this. All right. And one thing, Roger and I were kind of talking about this morning. And one thing that, again, as I mentioned, Corey did, which I liked, and I would like to do with you guys too, is I'll give you some time to work on it, but then next week, I'm going to walk you through how I did it. All right. And when I do that, I'm also going to do basically what you did, and as far as, even though you haven't learned it yet, we're just going to take our index.html file and we're going to save it as index.php. All right. And we won't have to do anything else with it other than change it. But we'll run it inside of the server because the idea is we'll create a heading, one file that you'll be able to include on all the other pages without having to change anything. Same thing with a footer. So that'll make it simpler for you. All right. And that's the kind of thing we go into next semester, but why shouldn't you learn it now? Because it's going to save you a lot of time and effort doing that. But to me, the 157 class is one of the cornerstones of the program. And if you didn't learn a lot, whether it's directly, whether you had me or you didn't have me, it's on me anyway. Because you have to understand this stuff when you go on and you take other classes. All right? Denny had talked to me and he said, do you have a problem with me teaching your classes? I don't have a choice. I like Denny. I don't have any problems with Denny. But it would be the same kind of thing if I asked, I turned it around on him once and I asked him, I said, well, would you like it if I was teaching courses in your program? Because there's certain things that he teaches in a certain way that I can't duplicate because I don't have his knowledge base. And it goes both ways. All right. So I'm sure he's doing the best job he can. But for instance, other people, there was someone who taught the 157 class a couple years ago, and that individual, 8 weeks into the course, announced to the class, I basically have taught you all I know. The rest of the stuff is in the book, and turn them loose. There were no other lectures the rest of the semester. But you know what? I asked later, there was not one person in that class who went in and complained to the dean about it. Not one. So, I mean, if that's the case, if you have a problem with me, whatever it is, there's certain things I've already told people I can't change. All right? I'm trying to change this, all right, but it's not coming in well enough. But my wife said, yeah, it's matching the color of your car. So I didn't want to grow this. She wants me to grow it. All right? That's my goal. I want to look like Roger. But she said, well, how long are you going to keep it? And I said, I don't have any idea. I said, it won't take long to get rid of the way it's coming in right now. So what we'll do next week is we'll kind of build it as a class. If you think, well, I got 25 out of 25, I know what the hell is going on, then don't come. Again, when people say that to me, is it's lab today? Do you mind if I come or not? Do whatever you want to do. All right? I'm so tired of that question. Really and truly, I am. When people say that to me, it's like, if you're going to go. Good luck when you're on the job and you say to your boss, hey, boss, are we doing anything important today? Because if we're not, I'd really rather go home. All right, the boss will, after once or twice, the boss will say, that's okay, stay home, though, the next time you go home. All right? Because we've had that happen. We've had students who have left this program and have done stuff like that. Well, my instructor in college let me do it. No, because I've been called on this by employers. And I said, no. It's lab. They are supposed to be there unless they have their work turned in. And they'll say, they'll show me a name. And I'll say, no, because that person didn't turn in most of their work. Well, then why didn't they come to lab? You'll have to ask them that. All right? My job is to be an instructor. My job is not to be a babysitter. All right? And there are people who, and I don't know if there's any in this room now, but there are people who come to classes, and they're second-year students. Luke knows who I'm talking about. That literally, when we have lab, they sit there and they play games all period. And they're typically the ones who write down when we have our evals. The instructor never gives us any time in class to work on assignments. That's true because I'm forcing them to play games instead. All right. So If you want to follow along, this has got all the code. I broke it up into 10 different lessons. So I'll give you a second if you want to do that. If you want to go out there and you go to the P drive for the class, in the in-class folder, there's a folder with today's date on it, all right, in both zipped and unzipped format. I have not yet taken the the zipped one, and put it out on Blackboard. I will do that by the end of the day today. If you go and look at that, just so you see it, what's in there is basically 10, for lack of better words, 10 different files. And then there's some images. What images? There's Bernie, there's the flag, there's Hillary, and there's the White House. And the whole thing is built inside of a Canvas. So there's also 4 documents that I put into Word, and from the Mozilla Developer Network, there's their Canvas tutorial. Here's the Canvas tutorial from W3 Schools. Here's the W3 Schools Canvas page. Probably the best article is this one right here. It's an HTML5 Canvas cheat sheet because it's got how you do everything in the Canvas. All right, so as we go through this, if there's something you don't understand, I would strongly suggest that you go and take a look at those. I'm not an expert in anything, all right? But I'm by no means an expert working with a Canvas, all right? I got this done, and I got it to do what I wanted it to do. All right, so really this thing that's called index, that's the last one. So I really truly quickly want to show you this. This is how I built it. I literally did part 1, then I saved it as part 2. Did part 2, saved it as part 3. Does that make sense? So when you look at it, here's the first one. It's just drawing a couple shapes on a canvas. Literally, that's all that it is. All right? Then in part 2, well, let's make a shape move across the screen. But you'll notice that it's still going. You just can't see it because there's no more screen. All right? So that's part 2. Then in part 3, it's bouncing. Okay? So you can see exactly what's happening right there. Call it whatever you want to call it. All right? Then in part 4, I started having it fall from the y-axis as opposed to the x-axis. But notice it just falls once. All right? In part 5, because I said, we got to look a little bit here at modularization and, come on. Yeah, thank you. I'll get it sooner or later. Thank you. All right. Now it looks exactly the same, but I substituted a for each loop in there just so you could see that. In part 6, kind of tough to see, but now it's going to bounce down. Now it's going to bounce back up again. All right. In part 7, now you've got it bouncing down and bouncing up, and you're now introducing this, but he's not moving yet. All right. I broke it up like that so we can take a look at the code for each one, and you can see what's different. All right. Is this well written? It's written. I'm not going to say it's well written. Then in here, now we don't care about collisions. See, I can go right into somebody if I want to, and you can't tell. All right. So that was part 8 of 10. Then in part 9 of 10, this is pretty much the finished product right here. So notice, all right, 1, okay? And then all I did for part 10 was I took these rectangles and replaced them with the images, all right? So all that makes sense? So I'm just gonna run through this with you, and hopefully you can get something out of it. I know it's funny, it was funny to see the look on Jory's face last week when I said I was gonna do this. He said, is it gonna be a game? And I said, yes, and he's like, really? Yeah, sometimes that is a really good way to learn, all right? So I'm just gonna open these up and start going over them one at a time. In fact, I'll just open them up one at a time. So again, all of them at the beginning, these are the same things that I saved for you. So those are those 4 Word documents that are right there, all right? So again, it started to get too big because I wanted to put the JavaScript in one file and but then after a while, that would have made 30 files in here. So I just put everything together, Okay? So here's the canvas, just kept it real simple. A 1 pixel solid black border. All right. Set up the canvas, made it 500 by 500. I changed the size in the last one. I tinkered around with it, so it's a little different here as opposed to the other ones. But these are the things I want you to understand out of this. Okay. I'd like everybody to understand the get element by ID. My hope was that for the one that you did for JavaScript, that would be what people would use. I know Roger did, and I know there were a few other people who did, but there were a lot of people who did not. I didn't specify it because I didn't want to cram down your throat and say you got to do it this way, you got to do it this way. But my hope is that everybody understands what that line means. All right? Whether you realize it or not, and I don't know if Denny has said this to you or not, but as an example, when you're in the C# class and you drag a button on the screen, all right, that button is an object of the button class. C# is a totally object-oriented programming language, all right? And what we're doing in here is we're basically treating this like it's an object. The document object, somewhere in there, we're hoping that it's got an ID that's called the canvas. So find that and just set it equal to canvas. Nothing magical about the name except it's a canvas, all right? If you want to be able to draw on a canvas, and I didn't do anything with 3D, so I just set it up for a 2D drawing object. So these two things, this is going out and grabbing something that exists. This is going out and creating something new. All right? Then when you do this, this is basically kind of imagine that you've got a stack of magic markers. And this says grab the red one, for lack of better words. All right? And again, when we're doing this, we're telling it here the X and Y coordinates and exactly where we want it to be placed on the screen. I think somebody had asked about this the other day. I don't remember, but just so you know, again, that is 0, 0. That point right there. In virtually anything that you work with in computer languages. All right? And the other thing that's a little weird, because I don't know about you, but I'm used to the origin being right there. And I'm also used to when I go this way, I'm going positive. When I go this way, I'm going negative. This way is negative, and that way is positive. All right? Well, the way we look at it here is we go this way, we're going up, we're going down, we're going left, and we're going right. So don't look at them in terms of positives and negatives as much as left, right, and up, down. All right? And that was it. Let's draw a second rectangle on the screen. And literally all I did here was the first one's red, and the second one, I just changed the color a little bit. So again, what you saw there, that was it. Not very much to the actual application, but just to show you that you can draw shapes on a screen. All right? Now that's a very short example. Oops. Any questions? I'm just going to keep going through this. So with both of them, it's done. The line is right here. Okay. So it's there for that's the second one, and that's the first one. And all I did in between there was I changed the fill style, which is just the color. Okay. All right. All right, so part 2. What's new? Well, now look what we're starting to add. We're adding the rectangle's X and Y coordinates. We're adding the rectangle's height and width. Okay? When I first did this, I didn't call them X coordinate, Y coordinate, width, and height. I called them X, Y, W, and H. So I went back and changed them all because I wanted the program to be somewhat self-documenting. So if you took a look at it, hopefully at least, you could figure out what was going on. All right? So other than setting up those coordinates right there, pretty much this stuff that's right here is the same stuff we looked at before. Okay? Now we've got a function in here that's called update. And we got another function that's here that's called draw. All right? And you've got another function here that's called move. Okay? And it's like, well, what is all that stuff? Well, notice it goes all the way through here and it sees all that stuff and it gets down to the bottom. That's the first function call that's actually in this program. So it calls move. And what does move do? Well, move is right here. Move calls those other two functions that are above. it calls update. As it says, it updates the position of the rectangle, and it calls draw. All right? It says call the method to clean the canvas and redraw the rectangle. When you're doing crude animation like this, basically what's happening is, if you look at it, here's our screen. All right? And we start off, we got this red rectangle that's right here. So what we end up doing when we draw it is we remove it. We literally remove it, and we redraw it just a pixel or two over from where it was. And we keep calling that thing several times per second. So it's got the idea that it's actually being animated, when technically it's really not. It's kind of being animated like, remember doing, I don't know if you ever did this, I'm dating myself here, but you know, when you used to sit there and put a little image on here and you'd flip through and you make it look like the person was moving. That's pretty much what we're doing here. Yes.
Basically, for gamers, it's the same concept as frames per second, right?
Yes. That's really is what we're doing. Yeah. And we're calling this several times per second. Yeah. All right. But we're doing it in more of a crude way, to be honest with you. All right. The other thing too is, notice here, I want to keep calling move. Well, this is going to call it originally, but I want it to keep calling. So what I'm going to do on here is move is going to keep being called because it's calling itself right there. All right, so the window is requesting an animation frame and it's calling move. All right, that's actually what's known as a recursive function. It is calling itself forever. All right, so it calls update first. And what's update doing? Well, basically it's changing, it's adding the speed, which the speed we set basically here to 2. For lack of better words, it's like we're moving it over a couple pixels. All right? And if you want to, I put this in here, you could even log it, and you could take a look and see that number going and up and up and up, but it's not that big a thing. Then the draw function, you've already seen most of this. All right? But the first thing right here that we want to do is we want to clear that rectangle out. And notice it's clear rect 0, 0, 500, and that should actually probably be a 500. All right, but it's basically going to clear the entire rectangle. All right, then we set a fill color, which is green, and then we redraw it again. And we redraw it based on our X coordinate and our Y coordinate, which we end up changing right here. The X coordinate keeps changing, but here, X is, so we're just moving horizontally along the axis. That's all we're doing. Does that make sense? Questions on this one? So again, all this one's doing is we're telling it to start right there and just keep going. All right? And if I refresh, it'll keep going and keep going and keep going. All right? Because I haven't put any more parameters on it other than that. So if I come in here and look at the third one, so notice animating the shape in both directions. All right? So one thing about this is you want to make sure you don't want it to actually hit the end and then start back. All right? Because what can happen if you allow it to hit the end is it can get stuck depending on how you write your formula. If you don't write it well, maybe you've seen that before, and it will sit there like this. That's not a good thing. All right, so I told it when it was about 30 to 50 pixels away to basically just change direction. So remember, this third one just says, okay, keep going there. Once you get towards the end, then switch and go that way. So it's the ability to animate in both directions. So that's what this one's doing. So I set up limits here. The minimum would be 30 and the maximum would be 450. I played with it a little bit. All right, even though it's 500 by 500, what you'll find is it's not necessarily 50 this way and 50 that way. You might have to jack around with it a little bit to make it do exactly what you want it to do. All right? So then in the update, now look, literally what this is saying is, okay, if I've reached that end, so if I'm within 30 pixels of the end, set it to 30 pixels, so don't ever let it get lower than that, and then reverse its speed. So make it go in the other direction. In the same way, If it's greater than or equal to, it should never really be greater than. But I could have said equal to, but just to be sure, we set it back again to 450, and again, we change the speed. All right, and regardless, that we tell it to move 2 pixels, either 2 pixels to the right or 2 pixels to the left. All right. Other than that, there's really nothing else that's in here that wasn't in the other ones. Like I said, that's why I broke it up into a bunch of different steps. So again, now it's being animated in both directions. 450, boom. 30, boom. And it may not be perfect, but it's pretty close. I mean, if I was actually going to put this out there for to have people buy it or whatever, I'd probably make some changes to it. All right. Any questions on that one? All right. So the next one on here, this is where they start falling from the y-axis. Okay? One of the first things is, you may or may not be aware of this. Again, I don't know what you learned last semester. Even if you had me, I'm not sure exactly what you learned last semester. All right? But one thing is, those are constants. Okay? And I could say const right there, but some of the older browsers don't recognize that word. So by putting it in there as a var and using uppercase, we're trying to send the idea that it's a constant. All right? And so I don't have to worry. If I wanted to go and change the width and height, I'd only have to change it in one place. All right? So now we're coming in and we're actually starting to do something that's more object-oriented. We're creating an array right here. And the array is going to have components. So these are the Hillaries that fall from the sky. And notice the first one starts at coordinate 100, the second one at x at 100, the second one at x 260, the third at 380, and the fourth at 450. Again, these could be changed any way you want to change them. All right? So you could space them closer or further apart based on that. They're all starting at the same y coordinate. The speed, notice that varies. There's 1, there's 2, there's 3, and there's 7. So that's going a lot faster. Again, you'll notice when you look at this, the last one is, boom, it's down already. All right? So there's a lot of ways that you could play with this, dink around with it to make it look a heck of a lot different. All right? And then when we come in here, well, again, this is the new code that's in here. This should make sense to everyone. What this is literally saying, as the comment says, is you're updating the position for each one of those Hillaries, which right now are the red rectangles that are falling vertically down the y-axis. All right? And in the next example, the only thing I changed was I changed this from a for loop to a for each loop. That's the only change that was made in the program, to my knowledge. And why? Because a for each loop will inherently run faster than a for loop. Because in a for loop, you always have your initialization, your test, and your increment or your decrement. But in a for each, it's all implied to be in there, so internally it will run faster. All right, but other than that, it's the same program. All right, and this draws the rectangle. But remember, now we have to draw 4 rectangles. This is drawing all 4 of those. All right, so again, it's done inside of a for loop. And I think we talked about this the other day, but if you look right here, please get used to doing this. The program would have worked fine if I would not have had this line in there, but instead, I would have typed in LCV less than Hillary's.length. It would have worked. But then every time through, it would have had to have recalculated that length. This way, it only has to calculate the length once, and it uses it 4 times. That's just smarter programming, all right? And that's the kind of thing, as you transition over, from your first year to your second year, et cetera, that's the kind of thing that you would be expected to do. This stuff that's down here is exactly the same. All right? Any questions on this example? So again, in here, notice when you write the for each loop, it's even smaller than a for loop. All right? Other than that, there's no differences between that one and the previous one. The next part, this added the bounce. So this said when you got down to the bottom, so it's very similar to what we did before. All right? Again, I hard-coded the numbers in there. I really shouldn't have done it like that, but that's okay. I said if it was less than or equal to 25, all right, set it to 25, and again, change its speed. All right, and here, I played with it so much that I changed that to game height minus 40, because it was like 330, 340, 450, 460. So I used the actual constant in there and used that in the calculation. But other than that, that's what's different in here. So again, you can see that there's more alike in each one of these than there is stuff that's different. Questions on this one? So what was new in here is we made a Bernie object. Notice the Hillary's was set up as an array. You notice because it's in the brackets here and it ends here. And also look at the syntax of this. Each Bernie object or each Hillary object, a comma after each thing except not after the last one, but since we're having multiple, you need a comma after each one of these except for the last one. All right? There's the Bernie object. And notice that Bernie has a thing there that's called is moving. All right, the question got asked before class, if you may or may not have been here, but when you're working with this stuff, how do you figure out, how do you make it stop and start, etc.? And that's part of the thing. You've got an is moving. It's a Boolean to show whether or not Bernie is moving or Bernie is not moving. So if we look in here, what we're saying is if he is moving, change his speed. If he's not moving, you won't change the speed. So you look in here. Oh, that's right, he was static. Okay. So I never set is moving to true. That's why he's not moving. All right. There's never a thing in here that actually sets it to true. But other than that, everything is the same. And notice how this is changing. Now notice when we're filling the rectangle. The name of the object, .x coordinate, the name of the object. You could write a fine game. The game would have been okay as it was, just using rectangles. Putting it in a way that, like I put it in, ideally made it a little bit more pleasing to the eye. All right. The next one didn't account for collisions, okay? So now, there's the Bernie moving is true, there's the Bernie moving is false. Now notice what we're doing in here. We're adding event listers. This is out of the book. All right, in other words, this says every single time you click down on the mouse, call move Bernie. And every single time you move up on the mouse, call stop Bernie. All right, so move Bernie is going to move him 2 pixels, basically not even a second. I don't know, however that happens. And every time I mouse up, it'll stop. But again, this one has not done any collision detection. So as I mentioned to you before, I can go right through people and it doesn't matter. There's 2 of them, and it just keeps going. So as it says, no accounting for collisions. All right. And then the last example that's in here, the last not full example, all right, number 9 does account for collisions, all right? And, again, it never fails to amuse me, for lack of better words, when I'll have somebody who will come up and talk to me, because a lot of times when I'm in here during the summer, potential new students will come in and talk to me and say, I really want to get into computers. I got some cool games and stuff I'd like to write. Well, that's good. Do you offer games? No, but we go into some stuff where we talk about what you need to know. Oh, okay, good. And almost always, whenever that's happened, the people will say to me, but I don't like math. And they don't realize that that's basically the thing behind just about every game. You may or may not have heard this. I'm sure Luke probably has before, but they've done studies. The people who are the most competent, who catch on to computers the fastest, are typically either mathematicians or music majors. And music majors, because music is just patterns, and math is just patterns. All right. I remember when I used to teach in a different technical college many years ago, and this woman came in and she said, "I've never even turned a computer on." I said, "What do you do?" She said, "I'm in this band, and I was a music major. I said, "Don't worry about it. You'll be fine." She had a job before she graduated. All right, and she was that good. Okay. So again, with this last one, when we start to account for collisions, and I guess I don't think I saved this article, but let's see, where is it? I tried to put some comments in that may or may not make sense, but 2D collision detection. All right. It's funny because I was talking with Mike Wegman about this between classes, and he said this was a really good example to show them because it had event listeners. It had a bunch of the stuff that was in these chapters that we just went over, and it even went over some collision detection. This right here in a nutshell basically said, okay, whether it's a width or a height collide, you know, I've got this guy who's coming in here, let's just say he's purple. And I've got all these bad guys that are falling from the sky and they're all red. All right? And what I'm saying in here, so there's 4 of them, as you know. All right? I want him to be able to traverse his way through there to eventually, hopefully there'll be a prize or whatever over there. And these guys are coming down here. And what we're doing here in that code that you see in gray is it's saying, is any part of this rectangle intersecting at all with any part of any one of those 4 rectangles? That's what it's saying. Because if it is, the game's over. If it's not, and I've reached the end, the game's also over because I know I've won. All right, so we're doing the collision detection here, and if you notice, we're calling that collision detection in the update function, which is called several times per second. So, if this returns true, remember that's a shortcut for saying if this equal true, okay, then game going is false. We're done. There was a collision. So we say, game over, game going equal false. Let the player know that they've won. Okay, hold on. Check for the collision. Okay. If this comes back, okay, and basically it returns that there was no collision, that's what's going to be here. All right? So, up here. So, Bernie has secured it. He's won. This just sets it back. If you didn't notice that, when you run this, I'll just let him lose right away. All right? As soon as I click this, notice how it goes back to the beginning. Everything goes back to their beginning positions. All right, and if I come through here, okay, same kind of thing when I click here. Okay. But what I'd like you to do, what I hope that you will do, if nothing else, is just bring up the last one that's just called index.html and take a look at it line by line, because I added other things in here also, such as, and I never had to do this before, so I thought what's in here right now, this is interesting. This is set up for a mobile device right there. When I said I never had to do this before, I never had it set up that where I put in HTML comments, I had to add non-HTML comments. Because even though this was commented out, all right, the system was still doing everything anyway. All right. What this is saying basically is account for my width, and user scalable equal no means I can't zoom. Okay, that's just the way that I set it up. All right. And what you'd probably want to do if this was being played on an actual phone is you probably wouldn't want the H1 tag in there. Because if it's on a phone, it's going to be taking up room that you don't want it to take up. You probably wouldn't want any padding. You probably wouldn't want any margin. You might want to change the background color. But you've seen how this looks. Okay, that's how it looks on a regular device. But if I come in here, in fact, I can do it from there. And this is how it looks on an iPhone 6. All right, so you'd see there's things that have to be changed. But notice, it still moves through. I probably wouldn't win on this one, knowing the way I am, but all right, but you get the idea. And how did I do that? Well, I went in here, then I went up to here on where it says toggle device mode, and I clicked right there, and then over here it shows me the different devices. So if I wanted to run it on a Google Nexus 7, that's how it would look. All right, these are just emulators right here. And the other thing is, if you notice in here, by default, unless told otherwise, just having the mouse up and the mouse down doesn't work. All right, so what you have to add also when you are working with mobile devices is touch start, which is like a mouse down, and touch end, which is like a mouse up. All right. But other than that, I think we've gone over just about everything. I did come in here, created an empty object that was called sprites. All right. And in here, that's where we loaded. We now have a load function, and that just sets up the background, the picture of Bernie, etc., all the other stuff. All right. But other than that, I think we've gone over everything that's in here. It was a lot faster than I thought it would be. As always, it takes me 10 hours to make this and get it to where I like it, and 1 hour to explain it, which I don't really like. But that's the way it is. So those of you who had problems with, you're behind or you haven't finished it yet, please take the time for the rest of the period today and all period on Thursday, all right, to try to make sure that you've got assignment 1 looking the way you want it to look. If you got 25 out of 25 and you're happy with the way it looked and stuff, whether you stay or not is up to you. Whether or not you come on Wednesday is up to you. All right? Again, a couple of, probably 3 or 4 in here, maybe 5, got 25 out of 25, and they were just really good. Adams was really good. And I was feeling really good because his name starts with B, and I thought, good, they're all going to be like this. And I was not right. All right? So you have time, if you had problems, to try to get that stuff fixed. If you didn't hear this morning, John should be back tomorrow. If you do have questions, I'll try to answer them for you as best I can. I don't have his patience. I wish I did. All right. But like I said, he should be back tomorrow. So he should definitely be back for class on Wednesday. All right. So a week from today, I'll show you how I did it. All right. And what I basically did was I went back, and I've actually saved this out here someplace. I think there might be a 224. I don't remember if I put it out there yet or not. No, so I don't know where I put it. But I went out and found an article online, which of course I still don't have up now. So let's see, that was under file, open. That. Yeah, whatever. I don't want to open it. So I literally keyed this into Google. Coding a CSS3, actually I said HTML5 first, but CSS3 and HTML5 one-page website. All right, and I guess they put the word template on there. All right, so I put that into Google, which basically got me to this, which is an article that's out there under tutorialzine.com, and it's a one-page site. This is what's in it, but what's nice about it, what I liked about it is it was simple, and what they explain in here is the HTML that they used. They show the head section, they show the body section, the article section, etc. to build this. All right, so I'm going to basically use some kind of an idea that's along these lines, and I'm going to use what they did, and that's what I'm going to use for my template to build that a week from today. All right, so if you think you can get something out of that, then come back a week from today. If you're leaving now and you're not going to be back till then. All right, there'll be no homework for this part. All right, I wanted to go over that game with you so you could see the stuff that was in there. Change it, do whatever you want to do to it. All right, questions?
How does that math work?
Well, I tried to tell you as best I could.
No, I understand that, but, because it uses the math tabs, I just don't.
That's the absolute value. So it says it doesn't matter which direction you're moving in.
Okay.
So if you're 30 and I'm 59, there's 29 years between us, whether we do 59 minus 30 or 30 minus 59. So what it's doing is it's checking as one guy is moving either this way, horizontally to the left or to the right, and the other ones are coming down vertically from the top or the bottom, and it's seeing if any parts of those rectangles, in this case, are intersecting with one another.
Okay.
That's exactly what it's doing. And if it sees any kind of intersection, it knows to stop. I don't know any other, maybe that's not the greatest explanation, but that's the best one I can give you.
So when you're passing the rect1.x minus rect2.x.
Rect1.x and rect2.x, it's the rect1 is the Bernie and the rect2 are the Hillarys. All right, and you're like I said, you're checking each one of them.
Can you do that with arrays too?
Oh, there's a lot of ways this could be done. Yeah, there's many ways this, think about how the program could be improved. You could set it up, if I get through, we could set up another level where we either added another Hillary or we increased the speed of everything that was in there by 1. So there's a lot of different ways that you can do this. You could come in and you could set up random numbers. So you could set up a random number, for example, between 2 and 5, that maybe sometimes you only have 2 Hillarys coming down, and maybe sometimes you'd have 5 of them. Or you could set up a random number of Bernies if you wanted to do that. So there's a lot of different ways the game could be changed. I'm not saying improved or not improved. All right, but the idea was to give you just a real little idea of how this stuff could actually be used. So you've seen things like registering. And the other thing, and I kind of went through this quickly, but the other thing that hopefully you noticed in here when you look at enough of these is when you start going through here and you say, what is this? All right. What we're doing is we're creating a function and we're assigning the function to a variable. That's one of the things that you can do in JavaScript and jQuery for that matter that you can't do in most other languages. All right. Some of them you can. And sometimes when you do this, when you have basically, this is an anonymous function because it has no name. So this is the function right here. All right, right there. We're saying take that function and assign it to this. So we're able to use it like a variable in our program. All right, you may have heard of the expression before. Java has them, not JavaScript, but Java has them. They're called lambdas, Lambda. That's pretty much what this is. It's not implemented exactly the same way in every programming language, but the ideas are very similar in virtually every programming language. Any other questions? So you know what's happening the rest of this week, and you know what'll be happening next week.